Copernicus is Europe's flagship Earth monitoring program. It has already started to deliver vital services in areas such as environmental monitoring, emergency response, civilian security, and understanding climate change. However, without strong engagement and uptake from end users in each of the EU countries, the program will not fully achieve its objective of delivering real benefit to citizens of Europe. For the Copernicus program to be a success, it is absolutely critical that end users throughout Europe are fully aware of the benefits of Copernicus to their activities, are adequately assisted with training, support, and specific measures to help integrate Copernicus information services into their own workflows and processes. The European Commission has rightly recognized that concerted effort is required to help users overcome barriers, improve their understanding, and receive facilitated support for integration of GMES information services. This webinar presents the results of the activities carried out in the framework of the GEO-LOT2 project to mainstream the Copernicus atmosphere services for the users to demonstrate how the service can provide support in different domains and to different categories of users. First of all, we want to pay your attention on how much air is crucial for our life. Every day we eat 1.5 kilos of food, we drink 2 kilos of water, but we inhale 14 kilos of air. Air is therefore an element essential for life, and the good quality of air is a fundamental need. According to the results of studies from the World Health Organization, the compliance of air quality in Europe with the air quality guidelines of the World Health Organization would result in nearly 90,000 premature deaths avoided per annum, 15,000 from cardiovascular causes, and 31.5 billion euros saved annually. After climate change, air quality is the second single topic covered by Copernicus with highest economic return on investment. The Copernicus Atmosphere Monitoring Service provides continuous data and information on atmospheric composition. The service describes the current situation, forecasts the situation a few days ahead, and analyzes consistently retrospective data records for recent years. Copernicus Atmosphere Monitoring Service supports many applications in a variety of domains including health, environmental monitoring, renewable energies, meteorology, and climatology. The service is delivered in a pre-operational mode. The products delivered by the Copernicus Atmosphere Monitoring Service are provided free of charge through the atmosphere.copernicus.eu web portal, which is operated by the EU-funded project MAC2. The service provides daily information on the global atmospheric composition by monitoring and forecasting constituents such as greenhouse gases, carbon dioxide, and methane. Reactive gases, e.g. carbon monoxide, oxidized nitrogen compounds, sulfur dioxide, ozone, and aerosols. The service also provides near real-time analysis and 4-day forecasts, as well as reanalysis of the European air quality, thus enabling a permanent assessment of the air we breathe. Monitoring and reanalysis of greenhouse gases and aerosols contribute to climate change studies by describing climate forcing. Thanks to daily analysis and forecast of UV and stratospheric ozone, the service supports public health policies, e.g. skin cancer prevention. Solar radiation is playing a key role in domains like health, agriculture, and renewable energies. The Copernicus Atmosphere Monitoring Service provides public and private organizations involved in solar energy usage with suitable and accurate information on the solar radiation resources at the Earth's surface. In addition to the above-mentioned services, the Copernicus Atmosphere Monitoring Service compiles emission inventories which serve as input to the atmospheric chemistry transport models and estimates net fluxes of CO2 and CH4 at the Earth's surface. Knowing emissions and surface fluxes are prerequisite for understanding the composition of the atmosphere. The main access point to the service is the web portal published at the address atmosphere.copernicus.eu. The site provides background information about the project, including the product portfolio and scientific information, as well as the access to the product catalog. Mainstreaming of the Copernicus Atmosphere Service. This section focuses on the mainstreaming activities, and in particular on the 3 test cases that have been implemented to demonstrate the value added of the service for different categories of users in different domains. The test cases have been identified with the purpose of demonstrating how the Copernicus Atmosphere Service can provide support to decision makers at different levels: national, regional, local, and to citizens. The initial proposal has been improved, refined, and validated by expert users that have participated in all the phases of the project, starting from the design of the test cases to the final assessment and validation activities. During the interviews in the initial phases, attention has been paid in gathering the operational requirements of the expert users. The first test case is focused on transboundary transport of pollutants and is targeted on decision makers at local level. The second test case is intended to support citizens in dealing with allergic rhinitis symptoms using the forecast provided by the Copernicus Atmosphere Service. Finally, the third test case supports decision makers in analyzing the pollution events to identify sources of pollution. Long-range transport impact on air quality in remote regions. Air pollution in urban cities is caused not only by local emission sources, but also significantly by regional atmospheric pollutant transport from surrounding areas. The objective is to demonstrate how local authorities can take advantage of the Copernicus atmosphere products to make decisions in case of pollution events, especially when this can be exacerbated by transboundary transport. The key points of this test case are the involvement of an operational user in the test case preparation and validation, and the support to the integration of the results in the decision-making workflow. There are several expected benefits. First of all, the demonstration of the added value of the multi-scale integrated modeling system for predicting the air pollution episodes caused by combination of local factors and long-range transport of pollution from more contaminated regions. Then, consideration of how decision-making in the case of air pollution episode is facilitated by transboundary transport combined with local emission. Finally, demonstration of the role that models, in this case for transboundary air pollution, can play in the decision-making process toward emission reductions. The results have been made available through a dedicated web portal. The prototype offers a direct and easy-to-use access point to the products of the Copernicus Atmosphere Service to those operational users who have the need of using information about forecasted pollution events but who are not experts in the Copernicus service. The prototype is also a basic decision support system, offering the possibilities to overlap external layers of information with the objective of assessing the situation. Pollen concentration observation and forecast for people affected by allergenic rhinitis. The objective of the second test case is to demonstrate how citizens can benefit from the Copernicus atmospheric service. realizing a diary that correlates the symptoms with observations from the Copernicus service. The key point is the exploitation of the integration of environmental and meteorological data. The expected benefits are the dissemination of Copernicus atmosphere products towards citizens and the demonstration on how Copernicus atmosphere products can provide benefits on a daily basis. Trees, weeds, and grass release tiny particles that can cause annoying allergies when they land in people's eyes, nose, lungs, and skin. Pollen gets spread by insects and particularly by wind. Main features of the developed prototype are interactive diary to annotate the symptoms to different kinds of pollen allergies during different seasons, comments on the symptoms and on the medicines took to prevent allergies can be saved daily. A rate can be assigned every day to monitor the progress based on the allergy therapy. A map is present to monitor and forecast pollen cores in the atmosphere. The application is available both in English and Finnish, particularly targeted to citizens. The results have been made available through a dedicated web portal. The type offers the log of the personal information every day, specifying the personal allergen, the symptoms, the therapy, and an overall score. This information is automatically correlated to the forecast map produced by the Atmosphere service every day. Since the test case is targeted to citizens, the user interface has been developed using the national language in addition to the English. PM10 pollution events in Central Europe. The objective of this test case is to demonstrate the capability to enable local, regional, and national authorities to use crucial information about AQ in near real time and to enhance their communication to the public in a comprehensible way. The key points are the involvement of an operational user in the test case preparation and validation, and the promotion of a primary source, the observed communication channels, for disseminating of AQ information. Expected benefits are the dissemination of results made more widely accessible and user-friendly, and the dissemination of Copernicus atmospheric products to decision makers and public to demonstrate the Copernicus atmospheric products value-added support to decision makers and public. On 24th of March 2007, the German station network recorded an outstanding PM10 pollution event. Analysis by UBA Germany, the Germany Federal Environmental Agency, showed that the high level of PM10 mass concentration probably originated in East-South Europe and were caused by forecast fires in combination with Sahara Desert dust. As the identification of natural causes for pollution episodes allow for the decrease of days with threshold exceedance to be reported to HE, the identification of sources of pollution episodes is of key interest for UBA Germany and other environmental organizations. Satellite data from Copernicus allow for identification of sources of pollution events and therefore facilitate the analysis of pollution episodes. Another result of the test case has been the improvement of a communication process, supporting the internal workflow and the communication to citizens. This slide presents the suggested process steps. The results of the test case have also been made available via Observe. Observe is an EU-funded pilot service making use of data provided through the European Earth Observation Programme and data that is available from local monitoring stations. To observe, European citizens will benefit from Earth observation, air quality monitoring networks, and air quality modeling from Copernicus. Observe aims to provide air quality information for European citizens, available as web-based air quality service and smartphone apps. Observe converts complex scientific results from EU research projects into easy-to-understand services for European citizens. Observe publishes its results via different communication channels, that is the website and also applications for iPhone and Android devices. You can access relevant information following the links in this slide. Thanks for your attention.